The Apollo program was NASA's third human spaceflight program, designed with the primary objective of landing humans on the Moon and returning them safely to Earth. It ran from 1961 to 1972, culminating in the historic Apollo 11 mission, when Neil Armstrong and Buzz Aldrin became the first humans to walk on the lunar surface. The Apollo program represented not only a monumental technical achievement but also a profound symbol of American innovation, determination, and leadership during the Cold War's space race. The origins of the Apollo program can be traced back to President John F. Kennedy's famous speech on May 25, 1961, when he committed the United States to landing a man on the Moon before the end of the decade. This bold goal was driven by the Cold War rivalry with the Soviet Union, which had already achieved several firsts in space, including launching the first satellite, Sputnik, and sending the first human, Yuri Gagarin, into orbit. Kennedy's announcement put immense pressure on NASA to develop the technologies, procedures, and infrastructure necessary to achieve a lunar landing. NASA had already started work on the Apollo program before Kennedy's speech, but his commitment accelerated its development. The program was named after Apollo, the Greek god of the sun, symbolizing the ambitious goal of space exploration. Apollo followed NASA's Mercury and Gemini programs, which focused on basic human spaceflight and developing techniques like orbital rendezvous, docking, and extravehicular activity, spacewalking. The lessons learned from Mercury and Gemini would be critical for Apollo's success. At the heart of the Apollo program was the development of the Saturn V rocket, one of the most powerful rockets ever built. Designed by German-American engineer Wernher von Braun and his team at NASA's Marshall Space Flight Center, the Saturn V was capable of launching the Apollo spacecraft on a trajectory to the Moon. Standing 363 feet tall, the Saturn V was a three-stage rocket that could carry the massive payloads required for a lunar mission, including the Command and Service Module, CSM, and the Lunar Module, LM. The Apollo spacecraft was composed of three main parts: the Command Module, CM, the Service Module, SM, and the Lunar Module, LM. The CM housed the astronauts during the mission, serving as the control center and living quarters. The SM provided power, propulsion, and life support for the spacecraft while in space. The LM was a separate spacecraft designed specifically for landing on the Moon and returning to lunar orbit. The LM was divided into two stages: the descent stage, which would take the astronauts to the lunar surface, and the ascent stage, which would return them to the CM in orbit. One of the most significant challenges facing the Apollo program was developing the capability for Lunar Orbit Rendezvous, LOR. This technique involved sending the spacecraft into lunar orbit and separating the LM from the CSM. Two astronauts would descend to the lunar surface in the LM, while one astronaut remained in orbit aboard the CSM. After the surface mission was completed, the LM's ascent stage would return to orbit and dock with the CSM, allowing all three astronauts to return to Earth. This method was chosen because it was more efficient and required less fuel than landing the entire spacecraft on the Moon. The Apollo program officially began with a series of unmanned test flights designed to evaluate the Saturn V rocket, the Apollo spacecraft, and mission procedures. These early tests were crucial for identifying and addressing potential technical issues before sending astronauts to the Moon. Apollo 4, Apollo 5, and Apollo 6 were unmanned missions that tested the rocket's capabilities, the spacecraft's heat shield, and the performance of the LM in space. These tests provided NASA with valuable data to refine the systems and prepare for manned missions. However, the Apollo program faced a major setback on January 27, 1967, with the tragic loss of Apollo 1. During a pre-launch test, a fire broke out in the command module, killing astronauts Gus Grissom, Ed White, and Roger Chaffee. The accident was a devastating blow to NASA and the nation, but it led to a thorough investigation and redesign of the spacecraft to improve safety. The fire exposed critical flaws in the spacecraft's design, such as the use of flammable materials and the highly pressurized pure oxygen atmosphere inside the capsule. As a result, NASA made significant changes to the Apollo spacecraft, including a new hatch design that could be opened quickly in an emergency. Following the Apollo 1 tragedy, NASA resumed its unmanned testing with Apollo 4 and Apollo 6, which successfully tested the Saturn V rocket. Apollo 7, launched in October 1968, was the first manned Apollo mission, though it remained in Earth orbit. Astronauts Wally Schirra, Don Eisele, and Walter Cunningham spent 11 days testing the command and service module systems, including life support, communications, and navigation. Apollo 7 was a success, proving that the redesigned spacecraft was safe for future missions. The next major milestone in the Apollo program was Apollo 8, which made history as the first manned mission to orbit the Moon. Launched on December 21, 1968, Frank Borman, Jim Lovell, and Bill Anders became the first humans to leave Earth orbit and travel to the Moon. Their mission was primarily to test the Saturn V rocket and the spacecraft's ability to navigate to and around the Moon. Apollo 8 also provided breathtaking views of the lunar surface and Earth from space, with Anders capturing the famous Earthrise photograph, which became an iconic image of the space age. Apollo 8's success was followed by Apollo 9 in March 1969, which tested the lunar module in Earth orbit for the first time. Astronauts James McDivitt, David Scott, and Rusty Schweickart performed critical tests of the LM, including docking and undocking with the command module, and demonstrated that the LM was capable of supporting a lunar landing. The crew also tested the Portable Life Support System, PLSS, which astronauts would use during spacewalks on the lunar surface. In May 1969, Apollo 10 was the final dress rehearsal for the lunar landing. Tom Stafford, John Young, and Gene Cernan flew the mission, which included a full test of the lunar module in lunar orbit. The crew descended to within 50,000 feet of the Moon's surface, practicing all the steps of a landing without actually touching down. This mission confirmed that all the systems and procedures were in place for the upcoming attempt to land on the Moon. The culmination of years of effort and technological development came with Apollo 11, launched on July 16, 1969. Neil Armstrong, Buzz Aldrin, and Michael Collins made history when Armstrong and Aldrin landed the lunar module Eagle on the surface of the Moon on July 20, 1969. As Armstrong stepped onto the lunar surface, he famously declared, "That's one small step for man, one giant leap for mankind." The astronauts spent about 21 hours on the lunar surface, conducting scientific experiments and collecting samples before returning to the command module for the journey back to Earth. The success of Apollo 11 fulfilled Kennedy's vision and marked a defining moment in human history. Apollo 11 was followed by 6 more lunar missions, with 5 of them successfully landing on the Moon. Each subsequent mission expanded on the capabilities demonstrated by Apollo 11, allowing astronauts to explore more of the lunar surface and conduct increasingly complex scientific experiments. Apollo 12, launched in November 1969, landed Pete Conrad and Alan Bean near the Surveyor 3 spacecraft, a robotic lander that had arrived on the Moon years earlier. The mission demonstrated precision landing capabilities, as the astronauts were able to land within walking distance of the Surveyor. Apollo 13, launched in April 1970, is perhaps the most famous of the Apollo missions for its near disaster. During the mission, an oxygen tank exploded, crippling the service module and forcing the crew, Jim Lovell, Fred Haise, and Jack Swigert, to abandon their planned lunar landing. The astronauts and mission control worked together to improvise a solution, using the lunar module as a lifeboat to provide life support and power as they looped around the Moon and returned to Earth. The successful return of the crew despite the life-threatening situation made Apollo 13 a testament to the skill and ingenuity of NASA's engineers and astronauts. The final 3 Apollo missions, Apollo 15, Apollo 16, and Apollo 17, marked the peak of scientific exploration on the Moon. These missions were equipped with the Lunar Roving Vehicle, LRV, a small, battery-powered car that allowed astronauts to travel farther from the lunar module and explore larger areas of the Moon. The astronauts conducted extensive geological surveys, collected more lunar samples, and deployed sophisticated scientific instruments. Apollo 17, launched in December 1972, was the final Apollo mission and included the first scientist-astronaut, geologist Harrison Schmitt, who played a key role in analyzing the Moon's geology during the mission. The scientific achievements of the Apollo program were vast, with the collection of 842 pounds of lunar rocks and soil, the deployment of experiments that continued to provide data for years, and the discovery of evidence about the Moon's history and formation. The samples and data gathered during the Apollo missions transformed our understanding of the Moon, revealing that it was formed through a giant impact between Earth and another celestial body early in the solar system's history. Apollo's legacy is not only scientific but also cultural and political. The sight of humans walking on the moon captured the imagination of people around the world and became a symbol of human achievement. The program demonstrated the United States' ability to compete with the Soviet Union in space and showcased American technological prowess during a period of intense Cold War competition. The Apollo program also had significant technological spin-offs, leading to advancements in fields such as materials science, computing, and telecommunications. Many of the technologies developed for Apollo, such as the miniaturization of electronics and improvements in rocket propulsion, have had lasting impacts on various industries. The program also set the stage for future space exploration, leading to the development of space stations, planetary exploration, and ongoing human spaceflight programs. Despite its success, the Apollo program faced growing opposition in the late 1960s and early 1970s due to its high cost and shifting political priorities. The program consumed a significant portion of NASA's budget, and as the Vietnam War escalated and social programs became a focus of government spending, there was less political will to continue the expensive lunar missions. As a result, Apollo 18, 19, and 20 were cancelled, and Apollo 17 became the last human mission to the moon. In total, 12 astronauts walked on the moon during the Apollo program, each contributing to the growing body of knowledge about our nearest celestial neighbor. While Apollo's lunar missions ended in 1972, the program left a lasting impact on space exploration and human history. It demonstrated that humans could live and work in space, paving the way for future exploration beyond Earth's orbit. The success of the Apollo program also highlighted the importance of international cooperation in space exploration. Although the program was a product of Cold War rivalry, it helped foster a spirit of collaboration that would later lead to joint missions with other countries, such as the Apollo-Soyuz test project in 1975, where American and Soviet spacecraft docked in orbit. In the decades since Apollo, NASA has continued to explore space, but no humans have returned to the moon. However, the lessons learned during Apollo continue to influence modern space exploration. NASA's Artemis program, announced in the 2020s, aims to return humans to the moon and establish a sustainable presence there, with the goal of eventually sending astronauts to Mars. The technologies, procedures, and experience gained during Apollo will undoubtedly play a crucial role in the success of future lunar and Martian exploration. The Apollo program remains one of the most significant achievements in human history, showcasing what is possible when nations invest in science, technology, and exploration. Its legacy continues to inspire new generations of scientists, engineers, and explorers, as humanity looks toward the next great frontier in space.